Carbon capture technologies are one of the effective mitigation strategies to tackle climate change. These are especially important when addressing hard-to-abate industrial sectors such as cement, energy generation, and iron and steel. This is where CaLby2030 contributes to the decarbonization journey. CaLby2030 is a European-funded project that aims to demonstrate emerging and cost-competitive CO2 capture technologies using a carbon capture technology called calcium looping, with the aim of achieving by 2030 large-scale commercial deployment of this technology in key high-emitting industries. But what is Cal technology? Calcium looping uses limestone, calcium carbonate, as a safe and affordable raw material to produce calcium oxide at high temperature, using oxygen and biomass in a reactor called calciner. The calcium oxide is then used for capturing the CO2 coming from industrial flue gases in a carbonator reactor, doing the opposite reaction and forming calcium carbonate, which recovers part of the energy input from the calcination. Afterwards, the calcination is repeated, generating rich CO2 and recovering the calcium oxide to be used in another cycle, closing the loop. The CO2 is purified and then sent to permanent geological storage or used as feedstock for industrial products. The CAL system is intended to be operated with the Circulating Fluidised Bed technology, or CFB, at its core. The technology has been developed and commercialized by Sumitomo SHIFW for several decades in various industrial applications. The CFB enables the efficient mixing and control of solids and gases reacting in the system, ensuring high CO2 capture rates, the efficient recovery of energy and calcium oxide. Why did we choose it? CAL is not simply a carbon capture technology only, but an enabler to decarbonize Scope 1, 2, and 3 emissions in several industries. CAL is a multi-service technology presenting numerous opportunities and synergies. Energy can be generated from the system to cover not only carbon capture purpose, but the industrial plant's own consumption. The calcium oxide can be redirected as low-carbon replacement material for industrial manufacturing processes, such as cement and steel. The use of recycled biogenic fuels can lead to negative emissions if they are stored or used for net-zero synthetic fuel production. Synergy with green hydrogen plants, where significant cost-saving opportunity exists if O2 as a byproduct from electrolysis is utilized in the system. How are we going to do it? 3 pilot plants will be put in operation using innovative CFB CAL solutions in Sweden, Germany, and Spain to investigate in relevant environments the adaptability of CAL to a variety of industries. Sweden, flue gases from steel-making processes. Germany, emissions from cement plants. Spain, biomass-fired CAL and waste-to-energy plants. Additionally, novel strategies to capture more than 99% of the emitted CO2 are tested in La Poretta pilot. The data collected will be used to develop modeling tools to scale up and address the engineering, commercial, and regulative frameworks to enable technology rollout to the market and support the decarbonization of industrial processes worldwide. The project consortium includes 18 partners, covering the whole value chain of industries and including world-leading research institutes in the field. Join us in this journey. Visit our website and follow us on LinkedIn, Instagram, and X to stay tuned on the latest news.